See, that's a weird one. All of our infrastructure is still owned by BT,
Oh, okay.
but there's loads of companies.
Oh, see, now it's saying it's
So you can
Golden
just switch.
It says Golden Hour AMA podcast. That is not what our thing is. It says, yeah. Looks like I gotta change this. There we go. Okay, now it's saved. Bum bum bum. Okay, this is how it looks. Videos in English. Okay, here, let's look at what this thing is real quick. I want to see. Oh, this is someone using it on. This is our Indian friends, all using it for the JEE exam. Let's see. Yeah, I get it. So it's a board, but then he's having to cast his video down here. Yeah. Would people prefer if I did it on like a dark mode? You know what I'm talking about? I don't know. Maybe it'd be better in dark mode. I don't know. I kind of like the bright white though. Oh, hi Joffrey. Joffrey says I like pre-calculus and cats. You have a question about something in pre-calc? We're gonna students.
Please seek your local therapist.
Questions on the stream. Oh, he makes bank, so he probably has all the tools. Yeah, yeah. You tell me that these guys make a lot of money just teaching physics. Any tricks for rational polynomial and quadratic inequalities? Ooh. It's actually a good question. Do you have an example question, Joffrey? If you have an example one, we could do one. Or I guess I could just look something up. Let me look something up real quick. Let's just say, yeah, this is like a good one. Ooh, like this? Yeah, I like this. This is a good one. Here, and then Aduki, we'll do your question. But here, I want to help someone out on the... So this is an example. They could give you something like this, right? I'm driving myself crazy trying to put everything on it. Yeah, okay. So this would be an example, right, of it's a rational, and it's a polynomial, and it's quadratic, and it's an inequality. So that hits like all three things, right? Whenever we get stuff like this, and no, Freak Bob, I haven't. I don't know what the NSEP is. Whenever you have stuff like this, it's cool to like maybe factor this out first. So you know you can factor this into, what is that? X plus 4, X minus 3, all over X minus 1. And then they say this is less than or equal to 0. Okay. Whenever I see stuff like this, I kind of just set it equal to 0, and what you want to do is look for, I say like they're like interesting points. I think they're also called like critical points sometimes, although that's a calculus term usually. But basically, you want to see what causes the top to equal 0 and what causes the bottom to equal 0. Because the bottom equaling 0 kind of breaks the function, and you want to know like what's happening there. Yeah. Oh, they call them cut points? Okay, cool. Yeah, so from here right away, right, you can see that like -4, +3, and +1 are all cut points. Kind of cool what they call those. So if I were to like I like putting these on a number line. So I'll put like -4 here. I'll put 1 here. I'll put 3. And then I know, since there's like an equal to 0, I know that these are going to be solid circles for these ones. So this is going to be solid. This is going to be solid. And this has to be open. Just straight off the bat, because if I plug 1 into this, like, I get dividing by 0, which is bad. We call this wavy curve. It's wavy curve, I guess. Yeah. So once you have this, all you have to do is just like check the different regions is what you do. And so I like to just plug points in. You can just plug a point in here. And so it's important. Be careful here. You want to plug it back into the original thing, because sometimes you'll start canceling stuff here, and that will technically like remove discontinuities, but you need to plug it into the original. Yes, yeah. This is open because dividing by 0 is bad. No. Can't divide by 0. Oh, since the leading factor is positive, you can do plus minus plus minus. Oh, I see. Let's see if that works out. That is a cool trick. Let's see if that works out. I'm just going to check a point. So I'm going to check, for instance, -5. I'm going to put it into here. Put it into the original thing. I know I can put it into here. I get the same answer, but sometimes your teacher will try to trick you with having things cancel out. So let's just put it in the original. What's up, Sensation? I heard toast. Okay, so let's try -5, for instance. Okay, so this gets me 25 minus 5, which is 20. 20 minus 12 is 8, right? And we have 8 over -5, which is less than 0. So that tells me that this area is good. Okay. So I think it's negative plus negative, actually, Freak Bob. Well, let's just see. Is there an intuitive way to understand the end behavior? I've already seen limit notation from applied calc, but I'm retaking pre-calc because I want to. Yeah, I can show you in a bit. So let's try 0, for instance. That's another point that's in here, right? If we plug in 0, I get -12 over -1, which is 12. That's not less than 0. So this is going to be bad. This is nope. Then, for instance, we can try 2. So that's 4 plus 2 minus 12 over 2 minus 1. So that's going to be negative as well, right? Because this is 6 minus 12. That's -6 over 1. So this is negative. That's good. And then we could try, I don't know, let's just try 4. 4, for instance. Try 4, you get 16 plus 4, 20. 20 minus 12 is going to be 8. That's positive over positive. So this is going to be no. Cool. Oh, from right to left. Yeah, you're good. Yeah, you're good, Happy Pot. We'll do it. So yeah, so then this is your region, and also this goes out to negative infinity, and this goes out to positive infinity. So if you were to write this in interval notation, you would say negative infinity, comma, -4. But you need to put a bracket here. Careful, careful. Because it includes -4. And then union 1, but it doesn't include 1, right? Because that's an open circle. And then to 3, but it does include 3, so that's a bracket. What if you get a surd, a number like 3 root 5? Yeah, you just have to know what the square roots are. You have to know how to approximate them. So you're saying, for instance, what if I get 3 minus root 5 over 2? You're saying like this? So, for instance, I mean, let's put this in factors of 2s, right? So this is 6 over 2 minus the square root of 5 root 2. I know that the square root of 5 is just barely bigger than the square root of 4. So I can kind of approximate this as almost just like 2. So then I would say like, okay, cool. So this is basically 3 minus 1. So this is around 2. So that's what I would use as my boundary point. You can approximate it. You can get close enough. Sure. Okay, cool. And then, yeah, for end behavior, it's a little bit hard with this. If you want to look at just end behavior of polynomials, right? You look at the highest power is what you do. And then you look whether it's positive or negative. I actually have a whole video on this have I done one of these? Yeah, here. I'm gonna show you the video I have. I have it. It's on. You like YouTube, obviously. I can tell. So let's look up. Where's my YouTube? I go here, and I go to. No, I'll get you the video. I'll get it for you right now. It's. I think it's graphing. Factor. I don't know. It's something here. Graphing factor. Here we go. How to graph polynomials in factored form. But I want like there's like a complete guide I made at some point. Because that was for YouTube Shorts. I could have swore I put it in here. Where's my playlist? Let's sort by date added. I think it was one of the newest ones. Find the domain. Where did I do it? Oh, did I not put the whole one on there? I really should have. Oh, that's kind of whack. One sec. What? I could have sworn I did. Where's like my studio? Content. Okay, I guess I did. That's a good thing. I should put out the full version, but here's the YouTube short, and if you watch it, it'll link to part 2 and part 3. I'll put that on my list. I should put all 3 of them on there as like a whole thing. It's because YouTube Shorts like limits me to 60 seconds, which is super annoying. They were supposed to remove that restriction, but I haven't gotten it rolled out to my account yet. Okay. Dudo says, hey, I have a question about integration. Can you show how to integrate using USub? Yeah, Dudo, do you have an example question? Can you just give me, just type it in the chat if you want, and I'll go do it. But let me help out Happy Pot. Happy Pot just posted one real quick. I'm glad we're getting some stuff in here. All right, let's see. Oh, is this you, Felicia? Is this parameterization? Oh, Jesus. He says, yeah. Okay, cool. All right, this is going to hurt. Okay. Use parameterization to find the flux of F is that in the outward direction, normal away from the x-axis, across the surface, cut from the parabolic cylinder. Jesus Christ, what? Z equals 1 minus y squared by the planes x equals 0, x equals 1, and z equals 0. I'm suffering in college. I would be suffering too if I was doing this question, dude. Like, I feel you, dude. Parameterization. This is where are we allowed to use like Gauss's law here? Because that's how you can do. You can do. For instance, if we have like E dot dA is equal to Q enclosed over epsilon naught. This is like an easier way to do flux calculations, but this assumes that there's a point charge, which I don't think there is. Let's see. I think you learn that next week. Okay, that's okay. In the outward direction, normal away from the x-axis, across the surface cut from a parabolic cylinder. Well, here, let me like try and draw this. I just want to see what this looks like real quick. X, Y, Z. So we have x equals 0, x equals 1, and z equals 0. All right, so that's going to be like this plane, right? That would be x equals 0. And then let's just say we have another one over here. Oh. I like this music. This music is a vibe, dude. What? It's a cello, too. Fuck yeah. Okay. Let's call this like x equals 1. This is x equals 0. Oh, I should really like put this over here then. My bad. Z equals 1. Okay, z equals the square root. Z equals 1 minus y squared. Okay, so is the same thing as y is equal to the square root of z minus 1. How do I want to plot that? Okay, so y is equal to 0 when z equals 1. Or it's plus or minus 2. We calculate the partial derivatives of the parameterization, and using the cross product, we can find the unit normal vector. We then calculate the dot product of f with the normal, and then we just integrate with limits. Sure. What's the parameterization, though? Okay. I guess it's a cylinder, so it's like you know, I'm like trying to draw my best. Yeah, it looks probably something like this. Oh, okay. And the radius is 1 then, right? Is that what we're saying? I think this is kind of what it looks like. Z equals 1 minus k squared. Oh, because they want it to be a double integral. In the outward direction, across the surface cut from... So we want to be integrating around here, is what we want. And then the normal vector to that. Is always just like... It's just always pointing away, isn't it? It's always like this. Oh, this is vector calc. Ugh. I almost want to like... I want to do this in like cylindrical coordinates, I feel like, don't I? Can I do this in cylindrical coordinates? N equals del R del U. Yeah, I agree. Yeah, I think we want to do this in cylindrical. You're saying that n vector is equal to... Or you're saying partial or del? Del is this, right? Del R del H? Oh, partial. Okay. I agree that it's partial R. Where's the partial H coming from? Is that because it's pointing... Oh, it's normal away from the x-axis. Wait, where the fuck... Where do you get an H from? Sorry. Oh, x equals H. Y equals K. Wait. Shouldn't x equal I, not H? One sec. Let me come back to this one in a second. This is going to take a lot more thinking. Let me help Dudo real quick. Just because... Yeah. Y'all think about that one for a second. Because I can't answer that one like right away. We'll get to it though. Let's see. Is this e to the 2 square root of x? And then over the square root of x? Dx? Okay. Oh, I know what we do here. So, anytime you're doing integration with u sub, you want to pick something so that the derivative shows up somewhere else, okay? What I know is that the square root of x, if I like take the derivative of this, is going to get me 1 over 2 square root of x. 1 over 2 square root of x. Because square root of x is the same thing as x to the 1/2. So the derivative of that is 1/2 x to the minus 1/2, which is then this. Okay? Which is nice because I see the square root of x here on the bottom. Okay? So if I say, for instance, let's say, let u, and actually, we can call this whole thing u. Let's say u is equal to 2 square root of x. This actually makes things even nicer. Because then watch what happens. So du dx is now equal to, we know this is 1/2 1 over the square root of x, but then we also have the times 2. So these are going to cancel out. So I literally just get 1 over the square root of x is du dx. Okay. So then the other way to write this is that du equals 1 over the square root of x dx. Notice I just moved the dx over. Okay. And then let's look at how we can substitute some things. So instead of e to the 2 square root of x, I'm going to say this is e to the u. And then here, look. Do you see how I have dx over square root of x? Dx over square root of x? That whole thing is just du. Okay. Now this is really nice. This is super easy. Because you know the integral of e to the u is just e to the u. So this is just e to the u. And then we substitute back in what u was. So then this just becomes e to the 2 square root of x. And you're done. So, yeah. The trick with u sub is, again, look at for, like, an integral that you know how to do. Like, I know how to do the integral of e to the something. So let's call whatever that something is as u, and then check to make sure the derivative of that thing shows up again. Yeah. Yeah, cool. Yeah, I hope that helps you out. I mean, that's the strat. Like, I know what e to the something is, so if I let this something equal to u, and then I take the derivative of it, I see that the rest of the thing shows up and cancels out, which is really nice. If it doesn't cancel out, then you pick the wrong thing for u. So, yeah, cool. Good question. Let's go back to this one. I need to brush up on my vector calc. It's been a while since I've done vector calc. All right, yeah, we're gonna try it. Okay, all right. So yeah, let's try to do things just all in terms of x's and y's. Okay? So yeah, if we were to rewrite this, let's see. Would be ni. Okay, so he's saying that the normal vector n would just be equal to, well, I hat. Is that what we say? Is that what you say for cap? I hat. Yeah. So here's like x. It's like x hat, y hat, z hat is equal to, this is like the ijk, which is what they're doing here for vectors. Okay. So, yeah, let's do a parameterization with r, right? So, the radius of this thing, r, right, is going to be equal to, like, some coordinate x in the I hat direction plus some coordinate y in the j hat direction, and then plus z. However, z is restricted, right? Z is equal to 1 minus y squared. So that's going to be 1 minus y squared in the k hat direction. Okay, cool. All right. So then the normal vectors to this is, like we said, in the I hat direction, right? The I hat, which is equal to dr dx. And then okay, I see. We're just doing all the partials. And then, so what is this? Okay, we'll see what we get. We'll try it out. So yeah, let's do the partials. So dr dx is equal to just I hat, right? Because we're just looking at this. And then dr dy is actually going to have two components now. So you're going to get j hat, and then this is going to be minus 2y k hat, because the derivative of this with respect to y is 2y, y to the first. Okay. So then to figure out the normal vector, I guess we just we cross these two things together. Is that right? Okay, so normal vector is then dr dx crossed with dr dy. Okay. So it's the partial of r in terms of y. This is r, right? So if I take the derivative of this with respect to y, I need to look for where there are y's. There's a y here, and there's also a y here. So that's why when I take the derivative of this, derivative of y is just 1 j hat, right? This is really just 1. And then the derivative of this is like 2y k hat. Okay? So what? This is I, j, k, and then it's going to be 1, 0, 0, and then it's going to be 0, 1, negative 2y. Okay. Okay, so the I hat component goes away because that doesn't do anything. We're gonna have plus 2y in the j hat direction. I'm doing the t method, right? So like I look at like this. So this times this. So that's negative 2y minus this, but then there's a minus on it as well. And then when I do this one, it's just going to be plus j hat, I guess, or just plus k hat, plus 1 k hat. Okay. So then, yeah, so now our normal vector is just equal to 2y j hat plus 1 k hat, right? And now we have to do f dot n, okay? So f dot n, which f is, well, so look, for the dot product, right, I only care about the j hat and the k hat component. There is no I hat. So that's xj minus 3zk. Dotted with 2y j hat plus k hat. And then we have the new expression, right? So z is equal to 1 minus y squared. So we can get rid of this. Okay. Drake. The Drake memes. I like these. These are good. Okay. One sec. Oh, f is z squared. Oh, wait, one sec. Okay, but I don't care about that one. Yeah, okay, this is just x. Okay, cool. All right, so now when I dot these, I should get 2xy minus 3 1 minus y squared. I think so, right? Okay. Okay, so we did f dot n, and now I need d phi. I need this. So d this is equal to dx dy. Let's see, right? X is gonna go from 0 to 1, and y is also gonna go from 0 to 1. Or no, y goes from -1 to 1. What's the temperature there? Oh, sensation's cracking up. Shh, nothing personal, kid, dude.
This one.
A dope shooting freak rubs the hands. Oh my god, that's too good.
Stupid.
No, dude, the humor is too good. All right, I think this is what we have. Let's see. 2xy minus 3, 1 minus y squared. Is this just, it's a pretty simple integral to do then, no?
What's a crotch?
What's up, Equity? Okay. You think you can do this? I'm curious what we get for the answer, because you said you got like 5/12 or something. What's up, Jeff? Okay. Well, here, yeah. Perfect. Check that one out. Let us know how it goes. I want to know what you get for the final flux and see if it matches up with what what's a crotch? God damn it. It's like, don't answer that.
If you don't know what it is in English, then you need to go back to school, like grade 1.
Yeah.
Now. I am a dumb motherfucker, and I know what crotch is.
It's 45 to 76. Yeah, I think it's like 70 degrees right now. It's pretty warm in let's see let's see what the temperature is. Yeah, it's 62. 68 degrees in Los Angeles right now. Or 69.
Nice.
Wow, look at that. 69 degrees. Yeah, it's super nice. Weather's pretty good. Weather's pretty good.
In December.
In December, yeah. I could go surfing right now.
That's the extreme.
I could go surfing.
I think it's 32, yeah.
Yeah. Yeah, let's see what we got for the answer here, Happy Pot. What do we get? I could do this in Wolfram. Yeah, because I don't know. I just don't want to. I don't want to do a whole integral. Or actually, I can ask ChatGPT to do this. Let's see if ChatGPT can get it right. I like their image recognition here. Do this integral. Okay, it's giving me a bunch of gobbledygook. What? Can you repeat that? There we go. They get to the flux is -4. That's a little bit different than what you got, Freak Bob, no? -4?
Okay.
What's up, Sai? Good to see you, dude. I'm at Unk status now, dude. What? Crotch? What is that? Did I do this right, though? I wrote out what R was. Right? In terms of X, Y, and Z. Then it did drdx, drdy, so we parameterized. Then we crossed them to get n vector, right? Should I have divided by n to get the unit vector? The answer is -4. Is that what the correct answer is, like, based on the solutions? Yeah? Okay, nice. All right, we did it. Okay. So, yeah, so in general, okay, try to always, like, convert to what the coordinates should be. In this case, like, R was, like, really nice, right? And then get the normal vector. And then just do F. Yeah, so you do drdx, drdy. Don't worry, I've set more of these to do. Okay, yeah. And then once we have n, which is in terms of x and y, actually. Okay, then we just do f dot n. Interesting. You'll get it soon? Okay, cool. All right, good job, dude. Good question. Ooh, we got some 5-point lining going on. Sensation, what's going on here?
Hang on.
Felicia. Okay. You're very welcome, dude. Nice.
That work?
Oh, there we go. You can see your hand. Oh, nice. This is how you're gonna do your writing stuff.
Like so.
Oh, I like that. Okay. We gotta get the focus on it. I don't know if it's focusing correctly.
I was just gonna start randomly taking photographs.
Okay, let's see. Aduki, are you around, Aduki? I think Aduki had a question next, which was this one. Yeah, Aduki's around. All right, let's do it.
Dude.
Draw a normal curve and label 1, 2, and 3 standard deviations on both sides on the mean, given that the mean is 121 and the standard deviation is 40. Okay, well, this isn't too hard. Yes, Ace, we can do yours next. I think you are next. Aren't you next? Yeah, you're next. Did you get the email, Ace, for the GeForce Now? Did it send out to you? Not yet? Really? All right, check your spam. It sometimes goes to spam. I ordered it this afternoon. I think it would show up. Okay. Well, it should come in sometime today. If it doesn't, let me know. I'll yell it in video. All right, so this is 121. And then, well, here, I want like a better thing. Let me see, like, normal curve. Yeah, I just want like a graph of one. So I can just have something that looks nice. Yeah, this looks beautiful. Let's take this. Because I could try to draw it, but it's not going to look as pretty. No, not that one. There we go. That's what I want. Nice. Okay. Yeah, yes, c e to the minus x squared. Yes, yeah, we could do it that way. Okay. This is actually kind of cool, because this is like what's called like the z-score. And then I can also say what I would be like the real score, right? I'm going to call it like the real score. Which, the mean, which is always the center of the normal distribution here, is going to be at 121. Okay. And then going up a standard deviation means going up 40. So this ends up being 161. Going up 2 of those is 201. And then we get to 241 here. And then going down, this is 81. This is going to be 41. And then this is going to be 1. Okay. Yeah, tell me a DM when it comes in. All right. So, yeah, that's how you draw it. Okay. But let's maybe talk about like why this is useful, right? So a lot of things in the world follow what's called like a normal distribution, which is kind of a graph that shows what numbers you get when things happen just like randomly. Like usually most things in life have a center value that things usually always hit, and then there's a little bit of deviation on both the left and the right. This, for instance, could be, I don't know, 121. Let's just say this is like IQ, okay? So let's say in a nice world that the average IQ of someone is 121, okay? But if I were to select some person at random, that they could be lower than 121 or they could be higher at 121. What a normal curve does is says that as I get further away from the mean, the probability, right, of finding a person on either side of that starts going down. Okay? This is why, for instance, yes, finding someone who's very smart, right, like above 201, this is a very small percentage of people, right? Because most people are around the mean. And it also works in the other direction as well. There's a cool rule here. It's I believe it's is it the 68, 95, 99.7 rule? Okay. Which says that 68% of the total population, 68% of the stuff, will lie within one standard deviation. So here, let's kind of draw that. Let's say like from here to here. So this, for instance, is 68% of the data. So if I wanted to select someone at random, and I wanted to know what's the chance that they have an IQ between 81 and 161, you would figure out the area under this curve, which would just be 68%. The other cool thing about z-scores and stuff is that the total area under this whole curve has to be 1. There has to be 100% chance of, like, something existing. That's kind of what we say. Yeah. And then if you want to go even further out, so for instance, you could go out 2 standard deviations. You can go from here to here. This ends up being 95% is what this is. So this is 95%. So we say 95% of all people have an IQ within 2 standard deviations, which means as low as 41 or as high as 201. And then if you really want to go out all the way out to, you know, out to 3 standard deviations, plus or minus, that gets you basically all the data, and that's 99.7%. Okay. So one thing they could ask you, for instance, is, you know, talk about Six Sigma. Yeah, Six Sigma is like, that's intense. This is also why you probably see on, like, advertisements and stuff, they say, like, oh, it fights 99.7% of germs or whatnot. They use these numbers a lot because they refer to specific things in statistics, which is 1 sigma, 2 sigma, 3 sigma. Yeah, this is also called sigma. I know you guys love the word sigma. So sigma is equal to that. This is equal to a standard deviation. Six Sigma. What's up, Zach? Good to see you, Zach. Zach, how's the thesis thing going? I think you put a post about your defense coming up. Shout out to Zach.
Actually,
Zach's a great guy.
It's my turn to mess with you now.
What do you want to mess with me? What do you want to mess with me, dude? What do you want to do?
So write capital Sigma.
Capital Sigma.
That's an easy one.
Is it this? What's capital Sigma? Is this? Oh, this is
Sum.
This is sum. Yes, yes.
And now write the other lowercase sigma.
Is something supposed to happen here? EO?
No. No. So sigma has a capital letter and 2 lowercase letters.
Oh, it has 2. What's the other lowercase one?
I can't spell it.
Let's see. The defense is coming. Oh, okay. Wait, no, it's just 6. This one, Sensation.
Am I wrong?
Oh, well, maybe it's this one.
There, it's that one there.
It's this curly one? Ew. What's that? That's gross.
It's a grammatical thing. Yeah, it looks more like that.
Oh, that's cool. I didn't know that.
Greek is weird.
Greek is weird, he says. Yeah. Yeah, wait, Zach, what's your... Sorry, I think you put it in your... Did you put it in your announcements? Let me put it on my calendar. When is... Where did you put it in? I'm going through your Discord real quick. Announcements. Okay, cool. Okay, here we go. There you are, Sensation. I'm trying to remember where. Did you put it in the elements? December 5th. Okay, cool. What time? Or do we know a time yet? It's live streamed? He's going to live stream it? So you probably put it in the mods only. Also available on Hulu. Is that with ads or without ads?
See, it's funny how everyone's still talking about streaming services and stuff like that.
I'd watch it on Hulu.
Loads of people I know have started buying NAS servers again. Stuff that was very popular in the early 2000s
Yeah,
when
like
the internet was very quite...
Like a Plex? Like a Plex server?
Yeah, just a small thing about,
Yeah,
big.
Yeah.
Anyway, apparently it's become a big thing now because people are just sick of streaming services, so...
Well, sick of I don't know. Streaming services were cool because it was, instead of paying $60 for cable, you could a la carte like what you wanted. But now people have like 6 different subscriptions. It's Apple TV, Paramount Plus, Peacock, Hulu, whatever the fuck. And like at this point, it's like $80 or $90 just to collect them all, dude.
And statistically, they remove all their good stuff.
Yeah, do they? Why do you say statistically they remove all their good stuff?
Because morons consume TV.
Oh, okay. Morons. Well,
and so they keep all the moronic stuff.
Like Love Island?
And things like that, yeah. But then that was true. That was true on broadcast TV back in the day. I mean, stuff got cancelled all the time.
Oh, I don't have a lurk yet. Do I need that with Enigma Bot? Does Enigma Bot is Enigma Bot up? Oh, maybe Enigma Bot is down. Oh yeah, I think Enigma Bot's down. Well, I think he was doing something to add it to the elements. Zach, what time is your defense set? Is that scheduled yet? I'll put down in my calendar it's on the 5th. But do we know what time your defense is at? Or is it on the elements calendar? I assume it's this one. But that would be kind of late for a defense. Right? Are they going to have you defend that late?
You've said this stuff, forgot. What's he defending?
Oh, Zach's not really... His PhD.
No, I mean... it's been mentioned what he was defending, but I can't remember what it was.
He... Well, yeah, his PhD's on... I think it was... Is that infinite series and sequences, or is that his master's thesis? I always mess this up. It's something math education really. Oh, no. It's about the comp exam, I believe. It's about the qualifying exam in grad school and analyzing it. I think his master's thesis was on like teaching sequences and series and like how that's a difficult thing in calculus to teach. And I think his PhD thesis is on the qualifying exam in grad school that students have to go through, which I have a lot of opinions on. We should have like a little round table on that at some point. Zach, for some reason, wants more people doing math. Yeah. I
have no idea what that is, but I'll have a go.
Yeah. So, what the comp exam is, Ace, here, I'm going to pull your question up. The comp exam is, once you get into grad school, at least in the U.S., everyone in grad school takes the same courses for the first year. And after that, after everyone taking the first year courses, there's an exam, usually late in the summer or early the next year, that you have to pass in order to keep doing your PhD. And if you don't, sometimes you get to retake it, but other times, like, no, you're just out, which is kind of shitty. So it's kind of like the one last exam you have to take in school, and it's supposed to be over everything you did your first year as a grad student. At least that's what it was in physics. I don't know if it's the same in math. Pretty sure it would be. It's kind of shitty though, because like you've gone through all this work and all this effort and the application process just to get into grad school, and then they like cut 30% of the kids within the first year. So it's pretty demoralizing.
What year of university is grad school?
It's after your master's, I guess, is what we would say. So
Okay.
in the U.S., it's right after college. So it's usually when you're like 21 or 22. You didn't, Adarsh. I got you, dude. Master's is grad school. It is, but in the U.S., at least in the science fields, you only really get a master's if you fuck up during the PhD. It's like a consolation prize, is what it is. If you see someone in the U.S. with a master's in physics, it's because they didn't make it past to the PhD. And so they let you leave with a master's, is how that works. Yeah, for sure. Yeah. It's an interesting thing. Okay, let's try to do this one, Ace. Okay, this is cool. So, we're trying to, these are trig identities is what we're trying to do. We're trying to prove that like two trig things equal another trig thing. So when you're doing these questions, you have to like just pick one side and then solve it and try to make it look like the other side. Usually they want you to mess up the left side. I gave you one, Adarsh. You should see it, dog. It's always in the chat. It's in the chat. It's right here. Okay. It's all right. So I see two fractions. What do I want to do, Ace, in order to like subtract two fractions from each other? How can I combine these as one fraction? Did I already do this one? I don't think I did this one. Common denominator? Yeah, exactly right, yeah. So when doing a common denominator, it's sometimes nice to just, I mean, if you want to make things easy, you just multiply the denominator of one by what the denominator of the other one is. So in this case, this thing is missing a 1 plus sine theta. So I'm going to multiply both the top and the bottom by 1 plus sine theta. I mean, maybe he did. And so then this one is going to get the 1 minus sine theta. Okay, cool. So now I can combine these things, right? So this is going to be 1 minus 1. That's going to be 0, right? That goes away. And then we have positive sine theta minus sine theta. So that's going to be 2 sine theta. So I get 2 sine theta all over this. Yeah, so let's see why it can be written as cosine squared theta. How is it 2 sine theta? Okay, because look. I have 1 plus sine theta minus 1 minus sine theta. So this minus becomes minus 1 plus sine theta, if I want to like move the minus in. And then 1 minus 1 is 0. Sine theta plus sine theta is 2 sine theta. This here is a difference of squares. So if you have a minus b times a plus b, that's going to give you a squared minus b squared. So in this case, this is a minus b. This is a plus b. So we're going to get a squared minus b squared. So that's going to be 1 squared minus sine squared theta. They do this weird thing with sine square. If it's sine of theta, they don't put the square here. Because then you don't know if it's sine of theta squared or sine of theta, like, squared. So if they put it here. This means the sine of theta times the sine of theta. Okay. Yeah, so this is 2 sine theta over 1 minus sine squared theta. And then, yeah, there's a cool identity here. Yeah, no, Jeff is trolling. We know that sine squared theta plus cosine squared theta is equal to 1. You should always remember this. This is a very important one. Okay. So if I wanted to move this over, right? Let's move this over. We get that cosine squared is 1 minus sine squared. Okay? So this whole thing becomes cosine squared. And I get 2 sine theta all over cosine squared theta. which is the same thing as 2 sine theta over cosine theta, cosine theta. And now this sine over cosine is the same thing as tangent. So I can write that as 2 tangent of theta, and then you're still left with 1 cosine theta down there. And there you go. That's how you do it. Yeah, it's pretty easy.
Well done! Well done!
If you weren't clever enough to see this, is there a methodical mechanical procedure that always works? I think always just converting things to sine and cosine eventually, like, causes things to sort themselves out. If you break everything down into sine and cosine, like, those are the building blocks, you can always, like, find a solution. Mainly suck on the 2 sine theta, but yeah, got it, nice. Oh, there you go, Equity. Equity's posted the same question for the last 3 days, but then you never hear Equity. Yeah, Equity always has to go soon. Yes, Equity, I can do yours. Jeff, I'll show you like some harder ones. Oh, even the double and the half angle. I mean, those you need to convert to like single sines and thetas, yeah. Okay, let's see what we got here. It says iron filings are sprinkled on the board. A conducting loop passes through as modeled below. Current flows. Okay. What pattern? So they're like. Yeah, I think, Jeff, just getting everything down into sine of theta, even if it's a double angle, just like converting it down, is I think the brute force way to do it. But anyways, yeah, if you have like a bunch of like metal filings here and whatnot, these things will align with magnetic fields. And what we learn about wires that have current flowing through them is you can do what's called like the thumb rule. They call it like the right hand rule or something. But if you take your thumb and you kind of like move it in like where the electricity is flowing in the wire, your hand wraps around to kind of form a circle, and this is what the magnetic fields look like. Okay. So in this plane, we end up seeing that it looks something like this. And then so if it's coming down, right? So if we're in here, okay, thumb is down, and I like curl my thumbs around, or curl my fingers around my thumb. Let's see. That's gonna do something like this. Oh, so they kind of oppose each other, right? Because look, this is going to be doing something like this, but then this is going to be doing. Oh, so they actually complement each other. Yeah. Okay. So their field strengths are going to kind of like add here. So let's see what that looks like. Yeah. Yeah, it's not this. This is if you, this is the electric field. It's actually pretty cool. This is what the electric field looks like if you have a positive charge and a negative charge. They connect like this. This would be like electric field.
Looks like a bar magnet as well.
It does look like a bar magnet as well. Yeah. So Sensation's right. Yeah. If you had like, for instance, a positive and a negative end of a magnet, yeah, the B field would look something like this. Yeah, that's just like a single magnet. This could be electric field or B field of a bar magnet. I agree with that. That's actually good. That's a good point, Sensation.
That's one of the few things I remember from school.
Oh, that's pretty cool. This is kind of weird. I don't know what this would be. I guess if this is like 2 positive charges, maybe. Or no, that's what this would be. This right here. This would be the electric field due to 2 positive charges. If you had two positive charges, because so how electric charge radiates, it radiates outwards this way radially. Okay. So if you have these two, they're kind of like opposing each other, and then you get like kind of this like no man's land here. And so like they bounce off each other. So this would be like the E field, and this would be two positive charges. I'm not sure what would cause this X pattern. But anyways, this is the correct answer, just because of what we drew here. You get like two circles. In this case, let me see. Sorry, these go counterclockwise, right? Yeah. So this B field looks something like this. And then this one goes the opposite direction. This one goes clockwise. And that's why they look like they both contribute here. Maybe if they were opposing. Let's see what it would look like. I think this is actually if the currents in the wire were opposing each other. Let's see. Yeah, okay. Okay, yeah, so you get the X pattern if they're going in the same direction. Very cool. Yeah. Is this EMF? Yeah, I mean this is so this would be well, it's actually kind of weird actually, but are they going the same pattern? I don't really feel like it. Dr. Mr. Gold, sir, could you show how 8 cosine theta to the 4th? Okay. Yeah, I could. Yeah, we could do it. Yeah, okay, this kind of looks like this, right? I see like the little V. Okay, cool. Yeah, anyways, yeah. Answer is C there. Good job. Are you learning this? I mean, this is E&M. This is physics, but even more so, it's advanced because usually you learn mechanics first before you do before you learn E&M. But it's cool stuff. I liked electricity. Someone was asking me like, what's my favorite thing to learn in physics? It is E&M. I really do like E&M. I like circuits, all that fun stuff. Very cool.
I thought circuits was EMF.
It is, but it doesn't go as much into, what should we say? Like it doesn't go as much. Circuits doesn't really go as much into like what's the flux through this or like what's this. It's more like what's the voltage here, what's the current here. We're not looking at like field strengths and stuff in EMF. In circuits. So Jeff says, can you show me how to do 8? Let's look at this real quick. 8. What is this? Cosine. Is this it? Theta to the 4th? Or is it cosine? Or is it cosine to the 4th theta? Minus 8 cosine squared theta? Well, okay, so what's to the 4th? Sorry. Cosine to the 4th theta. Okay, cool. All right, yeah, I got you. All right, so it's this. Oh, is equal to cosine of 4 theta. Oh. That's kind of cool. Is this true? According to Mathematica, yes. All right. So okay, I see everything here is in like just thetas, right? I don't like this 4 theta, so I'm gonna reduce this thing, right? Um, Where's my double angle stuff? Technically, I need a quad angle, but I don't want to do it. So I'm just do this one. I want to keep things in cosine as well. So I'm going to use this one. So let's use this definition. Right? So that's going to get me so we're going to say that whatever. 4 theta is equal to like what is this, like 2u? Well, here we'll say like u is equal to 2 theta. So really this is like cosine of 2u, which is going to equal to 2 cosine squared 2u minus 1, right? Or no, u minus 1. Okay. And then we plug it back in, right? So then that's 2 cosine squared 2 theta minus 1. Then we got to reduce it again. So that's 2 times, and then this is going to be 2 cosine squared theta minus 1 squared minus 1. Right? I think I did the reduction there, correct? Yeah? Okay, cool. So far, so good. Okay, so then this is just a minus b squared. A minus b squared, right, is just a squared minus 2ab plus b squared. So this is 2, and then this is going to be 4, oh god, this is gross, dude. 4 cosine to the 4th theta minus 4 cosine squared theta plus 1 minus 1. So 8 cosine squared theta minus 8, or cosine the 4th theta, sorry. Minus 8 cosine squared theta. And then it's plus 2 minus 1. So that just becomes plus 1. Oh. Yeah, which is the same answer. Nice. Yeah, it just comes out, right? Yeah, that's actually not too bad. Someone sent me actually a bunch of hard ones. I mean this is pretty easy, Jeff, but let me show you. Someone did send me some hard ones. Was it Zorn? Yeah, here. These are like pretty tricky. Yeah, see, we got some half angle ones in here and stuff. Here, Jeff, you pick one. Pick to your heart's delight. You want 44? Okay, cool. Let's do it. A little like gym workout. We're doing trig identities. Let's see you do that with sign. Well, okay. Mr. Sign Man. Fuck. Am I allowed to convert both sides to sine and cosine? Because I can do that, and then I'll just show that one side equals the other side. Yeah, let's do that. Okay. Yeah, I like this, right? I'm gonna regret this. I know I will. I'm so gonna regret this. But let's see. Okay. I want these to have the same denominator, right? So let's multiply them by each other, right? Hand you some more rope. Yeah. Yeah, let's just throw the grenade in while I'm at it, dude. Let's see. All right.
Grenades. Not as fun in real life.
Not as fun in real life, dude. I feel like this is gonna... Let's see if we have like some addition, subtraction things for sines and cosine. A good question for you, Sensation. Have you ever actually like thrown a grenade, like a real grenade?
Yeah.
Oh, that's cool.
I've thrown grenades. I've had grenades thrown at me.
Oh God. Yeah, they're kind of like unimpressive, right? Like in the movies and stuff,
Yeah,
I think they make them like into huge explosions, but in real life, they're not really that crazy. But I mean, they do a lot of fucking damage.
Yeah.
Yeah.
It's just a pop and smoke, but it's the sensation of a grenade going off, which is it's difficult to explain. It's unnatural.
Oh yeah, because it's a fucking firecracker, basically, like a really big firecracker.
Well, no, because it's like nothing you've ever felt before. It doesn't feel like a firework going off.
Oh.
You know, it's like
Oh, it doesn't. Oh.
the air tears itself, and it's.
Oh, there's a compression, like there's a concussion, I guess, right?
I don't know. It's when like a really big firework goes off.
Yeah.
And
It kind of knocks you back a
feel,
bit. You're like, whoa.
You feel a shockwave. You feel a shockwave, but it feels like a firework's going off. But when a grenade goes off in your face,
when a grenade goes off in your face,
it feels like nothing you've ever felt before. There isn't.
I'd
a way
imagine
I
it's
can
the
describe
last
it.
thing you feel.
Well, I survived without any scars on my face anyway.
Jesus. I always see the videos where they do like grenade training with the privates and stuff, and like because they have to throw it. And as the instructor, that's gotta be so nerve-wracking because if he fucks up, like you're both dead.
Yeah. Remember, it's like because this is like the early 2000s. Everyone had seen all the American movies where they pulled a grenade with their teeth, and it's like, go on, dickhead, try.
Yeah, just
Don't
don't
lose
do
teeth.
that. No, don't do that. Crazy, dude. I think that'd be kind of a fun little bachelor party thing, like throw grenades and stuff.
Yeah.
Yeah.
Have SWAT descend on you. Just
like. Let's see. This is gonna be a mess,
get
Jeff.
really smashed up and start throwing grenades at each other, and just SWAT turns up and it's like, "Are you the strippers?"
Are you the strippers we called for? It's like, no, we're not. You're the one that gave me the choice. I know I did. That's okay. I wanted this for myself. I really did. I kind of see how this is maybe going to work, though. It's kind of cool. And then this is plus sine y. Sine z. Yeah, right? Okay. God, this is going to be a mess. Converting all these. Let's see where we get to. Okay, so... And these are all multiplied by each other, right? Yeah. Thank God I have copy paste on this. Okay. Oh, I got 25 minutes, because then I got to teach another student. Okay. This is sine x cosine y minus cosine x sine y. Oh god, this is a mess. Oh, we have a cosine x minus y in both of these. Okay. I think some stuff's gonna cancel, dog. Okay, and then we need to do the sine of y minus z. Oh, I like that be right back. That's actually pretty sensation. So this is sine y cosine z minus cosine y sine z. Okay. Let's see. Let's see what we get. So this is this part, right? Cosine y minus z. Let's grab this. Okay. Oh god. I think it's gonna happen, dude. Oh man, it messed up my stuff now. Don't do that to me. Don't make it messy. Here, let's move this. Okay. And then it's plus sine of y minus z, which is this fucking mess. Oh, no, I screwed up. Oh god, we're running out of room. All right, let's move this over. Okay. And then cosine x minus y is this. All over. Tune in next time to find out. Dude, I hate when I'm like cross-eyed doing this. We got cosine.
Find out next time on Dragon Ball Z.
Dragon Ball Z. Cosine. Okay, this is this one, and then cosine y minus z, which is this. Okay. And what I'm trying to get this to like 1 plus tangent x tangent y, 1 plus tangent y tangent z. I want to like factor this stuff somehow. I think it's gonna factor. Because you see, I see the secant squared up here. That I know is 1 over cosine squared. So, I think I'm gonna be able to pull a cosine squared out of all this. Let's try that. I think that's what's gonna happen. Okay, so if I foil this, so let's take her all down, and then here let's just do what the bottom would be. So this times this is going to be cosine squared y, and then cosine x cosine z. Right? First outer. Oh, so that's not gonna be really nice. Inner. Yeah, I think I want to keep it though. I'm gonna show you why. And then the last. And then plus, they share this. So this is plus sine squared y.
Nice.
Thanks for the follow, dude. And then that's sine x, sine z.
Literally just sent them a message. Never mind.
What, Shrine Tricks? Who?
Yeah, same person from YouTube. I was about to send them a message, but they've already joined, so it's all good.
Oh, good, good. Oh, dude, my chat needs to, like, update. Yeah. What's up, Shantrix? Yeah.
Welcome into Actually Feet.
Actually, yeah. Right now we're doing, this is probably like high school, probably like pre-calc. It's like murder level pre-calc, but you can ask whatever you want.
I call next.
I call next. Let me.
No, really.
Oh, you do need help with that? I can help you out with that. Yeah. That's
Yeah.
Okay.
The explanation is weird.
Nice.
I feel like I want to pull something out of here, right? I feel like I want to pull out 1 over cosine squared y. Let's do it. I'm gonna do it. I'm fucking do it, dude. I'm gonna pull out a cosine squared y. Because I feel like that's gonna turn some stuff into nice stuff.
Cash-31 followed as well.
No,
because that's not an odd name.
What's up, Cash Dash? Okay. If I pull out a cosine...
cash.
You got the cash. Ass, cash, or grass, dude. No one rides for free. I think this goes here. And then this is going to be... So over a cosine squared y means that there's going to be a single cosine y down here, right? And this one will go away. Same thing here. This is actually pretty cool. And then this is going to be over cosine squared y. Okay, let's look at what we're creating here, though, right? So sine y over cosine y, that's the tangent of y, right? So instead of here, I'm going to like get rid of this. I'm going to call this tangent of y. And then this is also going to be tangent of y. Well, I'm trying to make it look like the other thing. It's like break everything down to sines and cosines and then simplify it and then bring it back up to what you need it to be. Right? Because then here's the cool thing. Because I have tangent of y in there. What else do I need? I need tangent of x and tangent of z. Because then I think... Oh, wait. This is tangent squared y, right? No? I'm dumb, right? Oh, yeah. This is tangent squared y. Oh, nice. Oh, nice. Oh, okay. Ah. And is this like kind of a quadratic? I'll like rewrite this as something. So then this is cosine x, cosine z, plus tangent of y. And then this is cosine x, sine z, plus sine of x, cosine of z. And then this is plus tangent squared y, sine x, Sine C. Which, man, dude, this is almost quadratic, right? Like, I could do the quadratic equation here if I wanted to, right? Yeah, I want to factor as tangent of y, because I think that's what's got to happen. Eventually, to get to here. You see how I have two factors? I think I want to factor as tangent. But, Christ, it's gonna be hard. Why don't you just admit the whole everything is a sine won't work? Because I like a challenge. Because of my ego. Because, yeah, I wanted to see if I could. I mean, solving the quadratic and tangent doesn't really count. Yeah, you're right. You're right. I wonder, though, if I converted this all down to sines and cosines, if I could have it match this. I think I probably could. I wanted to see if I could just, like, build it back up. Yeah. Here, let me do sensations question real quick, and then if I have time, let me build that up, and then I think I'll get to the same thing. All right, sensation. What's up? Which one you need help with?
I don't understand the explanation for B. It just seems all over the place.
Oh, okay, that's cool. Let's do it. 1 second, let me grab it. Okay, so we have x squared minus 5x. Oh, and they want to know how you factor it. Yeah.
It just goes, the big yellow box next to it is the explanation. It just goes off all over the place.
Yeah. Okay. So it's talking about that there are 3 things here, right? Okay. So this is technically a 1 because there's nothing in front of it, right? This is a 1.
Okay.
And so we end up saying, okay, cool. Look, like a is equal to 1. B is equal to minus 5. And then C is equal to minus 6. Let me rewrite these a little bit. Okay.
A, B, and C. Right, okay.
Okay, now in order to factor stuff, what you always do is you multiply this first thing by this last thing. So A times C. Okay.
Right.
So A times C ends up equaling negative 6. And then your job is to think what things multiply to AC. So what things multiply to negative 6, but add up to B. You see how it says find two things that give you B, the 2 factors of AC.
Look at the 2 factors of AC, which add that to give you B.
Because we have a couple factors of negative 6, right? So I can have 1 and negative 6. I could have 2 and negative 3. I could also have negative 3 and 2. Or I could have 6 and negative 1. These are like all the factors that multiply to negative 6, right? And I want which ones add up to negative 5.
Okay, so it can only be the first one.
Yeah, correct, right? It's only this one. Right? Because 1 minus 6 is negative 5. Okay. So then what you do, yeah, they say like just factorize it, blah, 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 is just rewrite this middle term as a sum of these 2 things. Okay? So I'm going to have 1x squared. And instead of saying minus 5x, I'm going to say plus 1x minus 6x. Right? Because 1x minus 6x, that's the same thing as negative 5x. Right? Do we agree with this? 1x minus 6x is negative 5x?
Yeah.
Okay. So I just rewrote that as this. Okay, and then we have minus 6. Okay. The next thing you want to do is you want to try to group things. okay? And try to factor as much as you can out of each one. So I'm going to group these two together. And then I'm also going to group these two together. So here, let's move them away from each other. Okay. So what's the biggest thing I can take out of 1x squared plus 1x?
X.
X, good. Yeah, okay, cool. So I'm going to take x out. And then that's going to leave me, right, with x plus 1. All right? What's the biggest thing I can take out of minus 6x minus 6?
Minus 6.
Good, yeah. So I'm going to say minus 6, and then what's left here, right, is going to be x plus 1.
Plus
right?
1, yeah.
All right. Now, these things are the same, okay? So I can now factor this even more by putting these things together. So I'm going to say this is the same thing as x minus 6 times x plus 1.
Right, yeah.
Right? Because
yeah.
This is always kind of the explanation. If I have like a times b minus, well, let me use different colors. A times b minus, I don't know, c times b. This is the same thing as a minus c all times b. Move this around. Because like you're pulling a b out of both things. And
Yeah,
you're just left with this. Yeah. So that's how it works. You just get to this. You want to try to make these two things the same. And then that becomes a factor. And then what's left on the outside combines into that one. Gold, just got an email and bought a new skin. Use code actual education. Dude, thanks, dude. Just got an email.
See,
what's up?
I've done this before, but it's like the explanation was just very odd.
Yeah, no, I agree. Yeah, they say like rewrite the bx terms in terms of these two factors.
But it was like, if they're explaining it this way, then there must be a point. So it's
Yeah.
like, please help.
I mean, they're kind of... I don't like the wording for what they're doing. Oh, you got the GeForce email. Sick. Nice. Yeah, we love the ad, dude. Sweet. I'm glad it came through. Do we have any more screenshots? Did someone post something? No. Yeah. So this can get like trickier, Sensation. So let's say, for instance, I had well, okay. So the simple way they also do these is at any time this thing is just 1. Okay. Anytime the coefficient in the front is just 1, look, so x squared minus 5x minus 6, you don't even need to multiply this by this. You just look for, like, what are the factors of this that add up to this? Which, again, right, is like 1 and minus 6. And then you literally just write x minus 1. Or, sorry, it's x plus 1, x minus 6. So whatever these numbers are, you just plug them in here. That's the shortcut. If this is just a 1 in front, if there's nothing else. Okay? This way, the way we did it here, by like separating the minus 5x into like plus 1x and minus 6x, that's the proper way to do it when this thing is not 1.
Okay.
Because that's kind of like the long form way you want to do it.
And I imagine it's, the higher coefficients are probably on the next page or something.
Probably, yeah.
No.
Oh, they're just doing exponent rules.
Can extend the rules of indices to all rational exponents.
Oh, wow. That's kind of like, what? That's kind of it's a non sequitur.
What's this page about? Hang on. Chapter 1 is about algebra and functions. So I guess it's all algebra.
Yeah, that looks like just
functions.
Yeah, that's like just a lot of like algebra rules is what it looks like. And look, they're also doing like rationalizing the denominator and stuff. Yeah, I see it. Yeah, radical. This is just kind of like a big overview of like all of pre-calculus or something. Someone send me a DM or something. I got a friend request. Who's sending me a friend request right now? Oh, no message requests.
I got pinged. Oh, no.
I got pinged. Nice. I'm glad you got it, Ace. Cool. I gotta do something sensation so that your face like comes up on the side here, on the podcast thing. Maybe we move you to like the top left, maybe. This is a bandwidth test.
There we go.
Thanks for the follow, Cash. Oh, Cash Dash. Cash Dash. That's a cool name. Cash Dash.
Whomst the fuck?
Whomst the fuck is Cash Dash?
Any more questions?
I don't think we have any more questions. Yeah. I mean, I was kind of like working on this one, but this is gonna hurt me. I'm gonna be really sad about this.
Oh no!
You got it.
I got it. Yeah.
Oh no! No, 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 no.
I wish I could make that sound. You know.
It's kind of funny. Oh, I do have to teach another student in 4 minutes. Okay, cool.
Oh, sure.
All right, we'll end the street out. And yeah, all good stuff. All right, cool. All right. Thanks everyone for coming to Actual Education Office Hours today. We appreciate all your questions and things. And if you found us on YouTube and whatnot, welcome. Please feel free to join our Discord server. It's the easiest way for you to like submit questions that you need help with, and we can make sure that they get answered during the stream. If I were to purchase bond coins with my channel points, how could I use it to screw over your viewers? I mean, there's no way to screw over the viewers. You could get gifts for kids. I don't care. Like whatever you want to do. But anyways, yeah. Our next stream's gonna be tomorrow, so that's gonna be an hour later. So that's starting at 4 p.m. Pacific, 6 p.m. Central, 7 p.m. Eastern. Come on by. We'll be streaming more math, science help. Ooh, what's this? Heroes? Oh, ooh, the Cadbury Heroes, dude. Oh, I like Quality Street. Quality Street's pretty good. Oh, it's an advent calendar. Oh, I love advent calendars. Those are so much fun.
You have these in the US.
We do. Yeah, we do. But they're usually like beer or wine or something. Like, watch. Costco Advent Wine Calendar. Have you seen this one before? Yeah. Oh, hi, Penn Center. Good to see you.
Oh, over here, advent calendars are exclusively, well, I was going to say for children. I suppose they are, but they're exclusively chocolate calendars.
Yeah, no, here like in America, we like to like go like, so we have like a wine advent calendar. You drink 24 bottles of wine, I guess, in like in a month. Penn Center says they do beer.
Sounds excessive.
Beer calendars. Yeah, was it beer advent calendar? Costco had one for a bit. It was actually pretty fun. 12 beers of Christmas. Yeah, 12. Well, it's the 12 days of Christmas, but this is the one. This was the one I remember that was on for sale. It was pretty expensive though. I think it was like $100 or something. Okay, whatever. Just accept all the cookies. But it was like it was the German beer advent calendar. 24 exclusively imported German specialties. Yeah. All right, they do some fun stuff. Chase Lee only observes Advent of Code. What, is there an Advent calendar for Code, man?
Oh no, Advent of Code is a thing.
Oh, is it? Oh, I didn't know that.
I've never taken part. It just always seems a bit over the top.
Advent of Code.
It's a bit like in the way that those maths questions you were just doing a minute ago.
Oh, it's just like really
over the top.
shit.
Why is everyone spiraling
I see,
over
I see,
YouTube
I see.
banning ads?
I see.
Just complexity for the sake of it, you know.
That was basically like what we were doing. Me drinking IPA. Yeah, this is what we were doing earlier at Penn Center. I don't know. This one was pain, dude. I was trying to show that you can solve like any trig identity just by converting things to sines and cosines, but then I ended up going down like a rabbit hole of just sines and cosines. I think I would get it, and we can try this later of like converting this. Well, no, I think I need to convert this. This reminds me of a problem from Saturday for me. Yeah. I don't know. I'm sure there's some identity with tangents, adding and subtracting. Where was it? It's probably in this one, right? Here we go. Tangent, add and subtract. Yeah, it's this. So tan A plus B is tan A plus tan B over 1 minus tan A tan B. So this is probably where it would come over it. Yeah, I would look up tangent identities. Yeah, I was trying to show. I wasn't trying to show. I was trying to see if I could just use sine and cosine to just eventually break down to like what it wants. But then I'm like at a quadratic in terms of tangent, and I wanted to find like factors that would turn it into this. I don't know. It's kind of a mess. Anyways, let's see. Okay, awesome. Let's go raid somebody before I gotta go teach OChem to someone else right now. Where's my stream manager? And also, Zach, yeah, let us know. Your defense is in 3 days. Like, good luck, dude. Let us know if there's a way for us to watch it, or yeah, or celebrate with you. I know we've done celebrations before on the streams, right? After you're done with stuff. I think someone did something and we celebrated. I think it was we celebrated your last class you had to take. It was like your last final exam or something. Yeah, I thought it was cool. Ooh, let's go say hi. Is Globus still streaming? I love Globus. He's such a cool guy. Globus is doing AI for visually impaired artists. Okay, let's go say hi to Globus. I think he's cool. Yeah, we'll do a party or something. Yeah, let's do it. Okay. All right. Anyways, have a wonderful rest of your Monday, rest of the week. We'll see you guys tomorrow. Enjoy your Monday. Peace out. Yeah, good to see you, Zach.